So let us begin with lecture number 9, that is evolutionary process 5. So this is the last evolution process that I will discuss. See, however, the switching and detection system of transmitter coil increases the complexity. Therefore, we just wanted to investigate on the receiver coils to reduce the complexity at the transmitter side to mitigate the lateral misalignment problem. Now, what we have done is we have proposed something called tilted receiver coil antenna. You can see the red one, the red part over here, the receiver coil. It is tilted along the x-axis, and the blue one is tilted along y-axis. Then what we have done is equation 26. These are the magnetic field distributions. Already you are aware of it. So using these equations, we have evaluated different transfer. You can see we have divided this transmitter coil, the receiver coil, into different differential areas. So each one is a small differential area. Each differential area of the row is actually locating at different transfer distances from H1 to HM. So this we have taken into the MATLAB and we have done some optimization. So before optimizing the tilt angle of the receiver coil antenna, so the transmitter coil's number of turns is optimized according to the IC NRPI guidelines, which says that the magnetic field strength should be 21 ampere per meter. So if you see that NT is varied from 1 to 7, and we understood that NT is equal to 6, is giving actually approximately 21 ampere per meter. So we have taken this as the optimal number of turns. So my transmitter coil number of turns is optimized to NT is equal to 6. Now you can see my theta for the receiver coil is varied from 0 degree to 70 degree. Then what I understood is at theta is equal to 30 degree, you can see this black line. So here I am getting the maximum induced voltage. Why I am getting maximum uniform induced voltage, not the maximum induced voltage. So why I am getting is under theta is equal to 0 degree, only the Hz is contributing. The moment you tilt the angle at 30 degree, what happens is the moment it is misaligning, how much ever it is reducing from the Hz direction, the same amount is actually increasing at Hy or Hx components. So in this way, I am getting the constant induced voltage. In figure 75 you can see. So figure 76 you can see the actually the analytical and the measured conventional and proposed designs. So if you see measured and analytical results are actually collaborating well with each other, but there is also one more important note is, if you see the proposed design, although it achieved a better misalignment tolerance, but at a cost of slight decrement in the mutual inductance. Why this decrement is there is, under theta is equal to 0 degree, the entire Hz is contributing towards the receiver plane. But the moment there is a tilt, under perfectly aligned condition, a part of Hz will be decreased because of the tilt, it will not receive a part of Hz component. So because of that, it need the value is slightly compromised in figure 76. Figure 77 shows the normalized efficiency evaluations, both with respect to the misalignment and with respect to the frequency at which we have targeted. The target frequency is 400 kilohertz. So this is the XY inclined receiver coil, as you can see over here. So this is RX1 and this is RX2. Both are connected in individually. We have taken and we have connected it in series. So this is the experimental setup. So what I wanted to conclude with this is the tilt angle being optimized at 30 degree in comparison to 90 degree is actually more feasible with the practical applications, because if you see the previous literary works, all the receiver coils are 90 degree tilted. So because of that, it is very difficult to apply it in the practical applications. Whereas because it is only 30 degree, the angle is very less, so it can be treated in a planar designs also. It can be treated well with the planar designs also. So here the first advantage is the uniformity factor is improved from 4.84% to 32.49%, and also from the misalignment tolerance minus 22 millimeter to minus 57,57 millimeter. has been enhanced from conventional planar receiver coil antenna to the proposed tilted receiver coil antenna. Therefore, the overall misalignment tolerance improvement is 571%. So the conclusive demerits of this objective is, although the proposed tilted coil antenna mitigates lateral misalignment and also reduces the effective height due to optimal 30-degree tilt angle, but the misalignment tolerance is less compared to the previous designs. Obviously, if you see, it is only 32.49%, which is actually less compared to what we have achieved in the previous design, which is 75%. So with this, I want to conclude the lecture. Thank you very much.